Time for some more kitchen table astronomy with Hampshire College astronomer and the head of Kainaat Studios, Dr. Salman Hameed, Mr. Universe. One thing that I love to do is any night look up into the night sky and see the stars and remind myself that every single star I see is a message from another time. It's like a time machine. While the light is hitting us all at the same time, this star over here on the left might have left 4 light years ago, and this star over here on the right might have left 20 light years ago, but it's all reaching us right now. This is how astronomers can look back in time. And astronomers have looked back in time far enough to see the birth of the earliest known galaxy so far.
Yes, and so that's a time machine part is really crucial. In fact, you might say, that we are cursed because we cannot see the present.
Right.
Because anything, including Monte, I'm looking at you, and the reflection of light that is coming from you, it's taking a finite amount of time.
Right.
Right.
The light speed between you and I is negligible, but there.
And so anything that you see, including the sun, that is 8 minutes old. So in some sense, we cannot see the present, but this allows us to track things in the past. And if we are trying to understand, and this is one of the big things for astronomers, trying to understand the origins, and it's for humanity as such, but about the origins, for example, as you mentioned about origins of galaxies, but also the origins of our own solar system. And our solar system formed about 4.6 billion years ago. We cannot go back and look at our own solar system. So this is also a problem because we cannot go back in that time machine to see our own origins, but we can look at other star systems that are being formed, and we can guess from there, oh, this is the type of thing that might have happened in our own star system. So this is about a couple of months ago, there's a study that came out that looked at a really new star being born. Its name is HOPS 315. And it's a yellow dwarf star. It's going to be sort of like, it's going to become like the sun, but it's just being born. It's actually surrounded by gas and dust. And this is how it happened in our own solar system. When our sun formed, it formed in a nebula, and around it there were other stars being formed as well. And out of that, there was a protoplanetary disk, which is protoplanetary again. So this is sort of like, the new planets being formed. Out of that disk became the planets. And so you have, all the planets that are in the solar system formed out of that.
Mm-hmm.
But that was 4.5 billion years ago. If you want to look at it just to investigate, but can we look at what the conditions were? You look at another star system, which is like our sun, in this protoplanetary phase, and we try to see, okay, can we see the earliest planets being formed? So astronomers have detected some big planets being formed. So like really in the disk, they have found like globs in it. Like, oh, this is sort of like, but usually those are big ones. But this is the first time, or this is that astronomers have detected like I would say the seeds of planets being formed. So this particular system, HOPS 315, it's like our sun, and it is about 1,300 light years away. So meaning to say, when we are looking at it, the light started 1,300 years ago, which for star times, that's actually negligible.
Yeah,
it's like
pretty
right
close
now.
by.
But here is the thing. This system, this HOPS 315, is only 100 to 200,000 years old.
Which is crazy because look at how old our solar system is. And then look at how old the universe is. What is it, 14.8 billion years?
13.8 billion.
13.8.
Right. But give or take a billion, who cares? But here is the thing. So 100,000 to 200,000 compared to the life scales of these kind of stars, like our sun, for example, where we are talking about billions of years, 4.5 billion years. This is like right in the beginning. This is pretty much the beginning of it. It's a baby. And so James Webb Space Telescope looked at it, and it detected some elements in it which gave a signature that it looks like something is solidifying These are the crystalline structures, or sort of like, the early seeds of that are going to turn into planets. And in particular, it detected silicon monoxide in there. And then there is another telescope, which is ALMA, which is in Chile, on ground, sort of like, on ground, not in space. That also then took an image of it in sub-millimeter sort of like, range of light. And it actually imaged that, and you can see here is a gaseous environment, and within it a star is there. Around it there is a disk, and usually there is so much material around the disk that you cannot see any of this kind of material. It's hard to see, but that particular star is a little bit inclined with respect to us, and we can see a little bit of a gap in it. And it is those gaps in which planets usually form. I mean, they clear out some space as well. So this is the first time that astronomers have detected these, you can think about these hot minerals condensing. So earlier on, this disk, this protoplanetary disk, is very hot. And this is what they found, and so it's all melted. But then you have these first crystalline, or you can think about this, some minerals forming crystals in there. This is what we are finding, that this is the earliest, in some ways, that astronomers can trace the formation of planets, the beginning of the formation of planets. And this is only 100 to 200,000 years old system.
Why is it called HOPS?
Well, so
it loves beer.
Probably, and it's a little slow over there. No. So HOPS, actually, this is interesting. So this is the Herschel Orion Protostar Survey. And so, okay, so that's a big name. Astronomers are
This is a good name for astronomy. Most astronomy names kind of terrible. HOPS?
Yeah, that's actually pretty good.
Yeah.
So this was, there was a European Space Agency telescope called Herschel. And it worked in the infrared, and in fact, for a while, it was the largest infrared observatory in space until James Webb Space Telescope supplanted it. And that was, I think, I think it retired in 2013. So it worked from 2009 to 2013. And because infrared can actually see through gas and dust, it is actually a really good, that's the reason James Webb Space Telescope is really good as looking at these star-forming regions, because it can go deeper into those clouds, whereas for optical light, it actually stops. So that's part one of it. But HOPS survey was actually, it actually looked at large sample of these protostars. So it was like, hey, let's look at a bunch of these protostars in the same cloud. So this is actually not in the Orion Nebula, but there's a cloud nearby, it's called molecular clouds. There are all these new stars forming because stars don't form by themselves. You have a stellar nursery. That's the kind of place where the sun formed, and there were other sort of siblings there. We don't know where it went, because over the period of time, over 4 billion years, they spread out. But when they're forming, you form hundreds of, usually a few thousand stars in those gaseous nebulae. So this particular survey is just looking at one particular cloud, so you know that overall conditions are similar, you know that overall roughly the age of the cloud is similar, you know what the composition is, but then it is looking at these protostars being formed, and they are analyzing it from multiple telescopes. And this is where it comes in, that you also have ground-based telescopes that are in there, you have space telescopes in there, and so they've identified. So this is HOPS 315. So as you can imagine, there are hundreds of protostars in this particular cloud.
Because this is the 315th in HOPS, using the HOPS method that they have found.
Right. And what I love about this, so this is where, I mean, in some sense, I mean, the appreciation of what astronomers do and how we try to solve problems, right? I mean, so they're trying to figure out, okay, so how did our solar system form? And so you don't go look at one star, I'm going to just look at one. No, so here is a group of over a few hundred protostars, and all of these protostars are in just one gas cloud, which is about 1,300 light years away. And there are, as you can imagine, hundreds of gas clouds like that in our own galaxy, or thousands of them. And of course, there are a few 100 billion galaxies. So we're not talking about that. We're just talking about this one gas cloud. But the other story that I love about this is that the telescope was named Herschel. Well, William Herschel was the one who actually had a telescope he built. He had the largest telescope in the late 18th century. He and his sister Caroline, in fact, worked together, and he actually is the discoverer of the planet Uranus.
Nice.
There you go. I thought you.
You always say it that way instead of the fun way.
And using his telescope, and when he discovered it, he wanted to actually call it the Georgian star.
But he's like, but you know what would be hilarious?
Hold on. But why Georgian star?
Because he's from Georgia?
No, he's in England, but for King George III. And I would say, boom, yeah, USA, because this is 1781.
Oh, yeah, wow.
Yeah.
So he named it after a part of your body instead, to try to show what he thought about King George.
But the reason why he and his sister, I mean, his sister doesn't get that much credit, but Caroline Herschel, I mean, she actually was later on, he was appointed as a court royal astronomer, and she was still the assistant to him. And so she actually assisted him throughout, and she was paid as well. And in some sense, Caroline Herschel actually became the first woman to be paid as an astronomer. And that is like sort of like, back in 1780s. So that's kind of cool. But he used his telescope to look at various nebulae. Anything that he saw, those were not stars, those were fuzzy and things like that. So at that time, we didn't know that some of these things are actually galaxies. So the notion that you have galaxies as a separate, sort of like the Milky Way, separate island universes as they were called, that was in the 20th century. But he was just looking at these things. He said, well, this looks like fuzzy thing. Here is a gas. I mean, now we know some of them were star-forming regions. Some of them were galaxies themselves. And he identified about over 2,400 nebulae. And what is really cool about this is just think about it, that a few hundred years ago, I mean, we had no clue. He's the guy who comes in and goes like, hey, here is a wonderful telescope, to which he actually ground the mirror and all of that stuff. And that process was really fascinating, because you had to not stop. And so he would actually, I think at one point he had to keep on grinding the mirror for about almost a day. And his sister fed him sort of like, at his mouth, because you could not stop doing that.
They literally
You had to mirror. Creating a mirror. And it was a big sized mirror, but the largest telescope at the time. And also he took time out from his music career, because he actually was a great musician as well. So he has actually musical compositions. I'm getting distracted by that, but sidetracked by that. But just think about it. A couple of hundred years ago, in 1780s, he identifies like, here are all these fuzzy things in the sky, these stars. I mean, he didn't know what was the nature of those, but here are these fuzzy things. They look like cloudy, gassy. And then we find out, well, okay, some of those are actually star-forming regions. Those are the regions where new stars are forming. Those are stellar nurseries. And then we come out in the 21st century and we go like, in one of the clouds, let's look at not just the big cloud itself, but within those clouds, we can identify several hundred protostars, where these disks around them which are just beginning to form planets. And now James Webb, with the help of James Webb Space Telescope and ALMA, which is the Atacama Large Millimeter Array in Chile, we actually look at it and we go like, now we have identified within the disk some of the first material that is condensing out of that, which is going to form planets. And we are looking at this star only 100 to 200,000 years after it was formed. I mean, this is just an amazing achievement, amazing story of when people say, well, what's the point of astronomy? Just think about how we try to figure out our own origins. And the scales and the way we have tried to put stories together. So sometimes people also come up and say, well, science says one thing today and one thing tomorrow, it always changes in mind. No, you can actually see how Herschel didn't know what those gaseous nebulae are, or the true nature of those, that some of them are spiral galaxies and some of them are gas clouds. Now we know which ones are forming stars, and within it, if they are forming stars, we should be able to find protostellar disks, which we do. And if they are forming protostellar disks, we should be able to find some of the material that is the seeds that will turn out to be the seeds of the planets. That is how science works. I just love the fact that this HOPS survey is just looking at these protostars, hundreds of them in just one gas cloud in the Orion, in the Orion constellation. The molecular cloud is in that direction, and which you can see these days as the winter is coming, you can actually see it after, I think, 10 o'clock or something like that. It's the most prominent constellation. Orion Nebula is there, but surrounded by this broad Orion molecular cloud.
So next time you have a beer, think of hops and think of the wonderful birth of this early solar system that we get to witness thanks to the ingenuity of astronomy.
And I should just add that alcohol, the molecules have also been observed in gas clouds out in space. So
Even space is brewing beer.